Hello everyone, today we're going to be talking about the life cycle of a star. So it all starts with a bunch of gas, which could be hydrogen. It's mainly hydrogen. Anyway, so where did this gas come from, you may ask? So it could be one of two things, a nebula, which is formed by a dying star, or it could be leftovers from the Big Bang. So now we have a bunch of gas in space, and it is getting closer together under the effect of gravity. And as it's coming together, there is greater pressure being exerted on the hydrogen atoms. As there's more pressure being exerted on the hydrogen atoms, they are gaining more energy and more heat. As this is happening, some of the electrons in the hydrogen atom can just escape the pull of the nucleus since they have such high energy. So now the hydrogen gas is actually ionized. That means that it's lost an electron or gained an electron. So this ionized hydrogen gas is now increasing its temperature because of the increasing pressure, and now at one certain point it can actually undergo fusion with another hydrogen atom similar to its kind. And that fusion triggers a fusion reaction, which in turn is the core of a star. And that is how stars are formed in the first place, from bunch of gas. So now we have a star, and the star stays like this for a long time since the fusion reaction occurs slowly and it is a very reliable energy source. So the hydrogen gas is the fuel for the star essentially, and this fuel lasts for a very long time. And the star, not much unlike our sun, is going to be staying at this stage for a very long time. So let's fast forward a little bit because we don't want to get old. So a little bit later, we are now going to be looking at a phase of a star which is called a red giant. Why is it called red and why is it a giant? Let me tell you why. So, as the star is getting older, it's running out of its fuel, and as it's running out of its fuel, it's also losing its energy to keep the core in the middle because it's running out of the pressure to hold it together. So essentially, the star is getting looser and looser. And as it's doing that, the core is growing in size because there's nothing holding it together. The pressure is gone. And as that star is growing, it gets a reddish color and a giant size. Henceforth, the name red giant. So this star will grow and grow and grow. And in the case of the sun, it as it's growing in the red giant phase, it may swallow the earth and everything in front of it. So right now the star is in a red giant phase, and you may be wondering what happens next. Well, at one point all the hydrogen fuel must have been exhausted and there's essentially nothing to hold the core together, and of course it's going to collapse. But as it's collapsing, all the matter also has to go somewhere. So it gets ejected out, and all the gas which has been kept here for so many years just gets ejected out. And since they have all been under such immense pressure, they've undergone changes in their properties, which could result in change of color of the gases, which is why nebulas have such beautiful color. So this could be made up of many different colors. Just imagine this to be a nebula. My drawing skills aren't that immaculate, just imagine please. So right now this is supposed to be a beautiful colorful nebula. made up of all these different gases which have been formed as the star exploded. And in the center, there is still a very powerful core, and that is something that you would call a white dwarf. This is the final stage of a regular star. I just said a regular star because there is another way the life of a star can go. Let me show you that. So let's rewind a little bit. Now we're back to the stage where there's just a bunch of gas. So now let's just talk about the other phase. So what I showed you before was the life of an average star. Now let me show you the life of a massive star. So these massive stars, they are much huger and are much more powerful and brighter than our star. In fact, they're not even always yellow, white, or those kind of colors. They could be blue in color because they are much hotter than our star. And they could be white, which our sun's color is, but it looks kind of yellowish because I drew it like that in my kid days. Anyway, so now we have this huge supergiant star, and let's fast forward again when it turns into a red supergiant. It's no longer a red giant, but a red supergiant. Red supergiants also have a more deeper reddish hue, which gives them a much distinct shape. I mean, like, yeah, shape, size, and color. So that's why I'm using a darker red paint. So now this huge red giant doesn't even fit onto this canvas. So let me just cover the whole thing for now. And since this has such a huge core, it doesn't just simply collapse and form a nebula, it actually creates a beautiful explosion which is known as a supernova. This supernova is visible across many light years, and in fact, there is a star which is visible from Earth called Betelgeuse, which is going to go supernova in a few million years as it's predicted to happen. Anyway, so right now it is a supernova and it still has a very active core. So at this point, the core can collapse to form two different things. Number one, it could form a neutron star, which is made up of neutrons, which is a subatomic particle. And this neutron star is very unstable. And in turn, this unstable star could spin at very high rates, such as 43,000 rounds per minute. And that is a very highly spinning body which possesses lots of energy. So let's move on to the other thing that a supernova can form. This is the worst fear of mankind. It is a black hole. As the core collapses, it sinks in essentially and creates a hole in the fabric of space time called a black hole. Yeah, and that's it. It's probably gonna suck in everything in its path and just eat up everything it just created, and probably some distant galaxies of some sort, and like lots of stuff. And yeah, that's pretty much it. And that's a life cycle of a star explained to you by a 12-year-old. Bye.